Hello, I'm Ajar Soy from Huawei Global Training Center. Today, our class is about Key NFV Capabilities. The first capability is its openness. This makes VNFs compatible with multi-vendor platforms, provide stable performance, and run on COTS hardware. Before putting an NFV network into commercial use, the hardware stability must be tested. Furthermore, as mentioned in previous sections, an NFV network can use hardware from different vendors. For example, an NFV network can use the VNFM from vendor X and NFVO from vendor Y. In addition, the VNFM and NFVO can be integrated with existing platforms, such as the U2000. In short, an NFV network is an open environment that can run multi-vendor applications and is deployed on COTS hardware using a standardized cloud operation system. These two terms, virtualization and cloudification, are different. The cloud architecture is the basis for elasticity and reliability. Hardware and software are coupled on the traditional platform. For example, the hardware for IMS networks must be deployed on the ATCA platform. In virtualization, the software is decoupled from the hardware and therefore software can run on standardized hardware. Service logic and data are still coupled. The NFV architecture is required to have refined control to help developers deploy network functions and sub-functions. It should automatically allocate workloads based on carrier strategies and resource accessibility. It also should manage distributed data centers and networks as separate virtual clouds. O&M personnel associate and analyze events obtained from different sources to monitor cloud platform performance in real time, therefore improving the efficiency of decision-making. In the cloud architecture, the software is decoupled from hardware. The business logic layer is decoupled from data layer, and the session forwarding layer is decoupled from the service logic layer. Take the CSCF for example. CSDPU VMs on the session forwarding layer are responsible for sending and receiving packets. CSSCU VMs on the service logic layer are responsible for processing business logic. CSRDB VMs on the data layer are responsible for storing subscriber service data, such as active call data. Subscriber data is stored in different active RDBs and synchronized to standby RDBs, thereby simplifying the flexible deployment of a distributed database. In addition, active standby redundancy is supported. Flexible refers to a scale-out can be completed in minutes and the scale-in can be completed in seconds. When service traffic increases, active RDBs will generate new VMs to process more data. Only dynamic data, such as subscription, office direction, and active call data are stored on RDBs. Therefore, dynamic data can be used to generate VMs to support new businesses. When service or call traffic decreases in the night, services can be migrated to one VM. Other VMs can be powered off to reduce resource usage. Other VMs can be automatically rebuilt when specific call traffic must be processed. Redundancy policies are available for applications, cloud operation systems, and hardware layers. On the application layer, VMs can run as active or standby or for load sharing. When the active VM is faulty, the standby VM automatically takes over services. The load sharing redundancy is also called stateless N+M redundancy. M VMs are for load sharing and N for redundancy. When one VM in the load sharing group is faulty, a redundancy VM takes over the services. On the cloud operation system layer, VMs are rapidly rebuilt for service redundancy. When a VM is faulty, a generated VM takes over services. On the hardware layer, hardware is clustered and redundant hardware is used to ensure the computing, storage, and networking resources are correct. Reliability of hardware, VMS, and service layers is independent and supplementary to each other, ensuring system-wide availability. The redundancy mechanism on hardware and cloud operation system layers ensures that resources are always available. The redundancy mechanism on the application layer ensures that services on the application layer are not interrupted. Therefore, the reliability of the whole network satisfies the carrier's 99.999% requirement. SpecWord is a computer benchmark that evaluates the performance of a server for virtualization. According to its evaluation, the performance of Huawei's FusionSphere is scored at 4.6 and leads the industry among VMware and Red Hat Linux. FusionSphere can process calls 17% higher than that of VMware. Many key technologies such as NUMA affinity, CPU bounding, DPDK transparent huge pages, and interruption minimization in a virtual environment are used to ensure high-level performance. Though NFV has developed rapidly, there are still some problems. First, the NFV standard has yet to mature. There has been much dispute over the NFV architecture, such as whether the NFVO is an open resource system and what is the relationship between EMS and VNFM. Second, integration is complicated because of the multitude of available vendors. NFV is a huge ICT integration project that deals with the automated deployment of service networks. Vendors can provide hardware, NFV system integration services, and virtualization, cloud, telecom, and NFVO software. Third, the compatibility of multi-vendor equipment is difficult. NFV only defines the network architecture. Interfaces, however, are defined and implemented by other technical or open source groups. Fourth, NFV projects are complex. The NFV architecture is a huge ICT integration system. An NFV project involves multiple vendors, different equipment, and multiple interfaces. Therefore, building an NFV network is more arduous than building a public or private cloud network. Fifth, network virtualization technology is lagging behind. When comparing computing, storage, and networking virtualization technologies, it is quite evident that networking has yet to mature and the reliability of virtualization is poor. NFV still has room for improvement if vendors are to reach the traditional telecommunications standard of 99.999% reliability. Very well. In summary, NFV is a technology with enormous potential, yet due to its novelty, it does have some shortcomings. Okay, that's all. Thank you.